Hey, what's up everybody, it's Ivan here, and so this video is going to be a project that's several months in the making. It'll be a TensorFlow Lite age and gender estimation app that runs on Android devices, but like even broader than a, TensorFlow Lite age and gender estimation app, you can think of this video as kind of like how you can train a TensorFlow or a Keras neural network, convert it into the TensorFlow Lite format so that you can then run it on like Android devices. And what's even better, in this video I'll share the code for this app on GitHub, and I'll also upload the entire project on Google Drive such that you can have like as easy of a time as possible getting started with this. And so guys, if you're excited, smash that like button, consider subscribing, and let's jump right into it, So you can think of this video as kind of a story time basically, where I'll do a walkthrough and I'll show you like all the caveats that I found, things that were not clear, and I'll try to like give you the code and the general picture of how everything works. Starting with the neural network. So the place where I started is having trained a Keras age and gender estimator on IMDb Wiki dataset, which is a dataset of like 400,000 face images of celebrities that has like the labels for the age and gender. I've made a video on that dataset. It's a pretty cool dataset. So I have trained a model, a Keras model on it, and then essentially to convert that Keras model, to convert that .h5 model into the TF-Lite format, it's like really simple. And the code here is pretty much the code from like here, from how to convert the Keras model into the TensorFlow Lite format. And so if I run this cell, it'll pretty much give me from my face model. If I will give me the it'll essentially give you the TF-Lite model, and it's the same like Keras model, just in the TF-Lite format. I found this pretty cool piece of software called Netron that essentially allows to visualize neural networks. And so a few things about this particular neural network is that input size is 80 by 80 by 3, so it's got colors and all that. And the real unusual thing, and essentially it's like a simple kind of neural net where it's like kind of layers, and then it's two fully connected layers. And then the thing that's like unusual that I did is essentially put age and gender estimation right into a single network. So there are a bunch of convolutions happening here, and first fully connected layer, second fully connected layer, and then there are kind of like two output layers. And the first output layer has 4 nodes for 4 like types of ages, basically from like 0 to 14, from 15 to 40, from 40 to 60, from 60 to 100. So you can think of that as like children's faces, like young adults faces, then like middle-aged people ages faces, and the like old people faces from like 100 like onto like 60 and all that type thing. So that's like what the first kind of output layer stands for. Hi, it's Ivan from the future, and I just wanted to really quickly clarify that the reason for this exact split of age classes is to account for inaccuracies in the IMDb Wiki dataset, which is dataset of a bunch of celebrities, and it was scrapped from the internet, so it wasn't like hand labeled, such that there's like a clear difference in the facial structure of the different ages. So hope that makes sense, And the second output layer has 2 neurons, and you probably guessed it. It's either it's a male face or either that's like a female face. And so then both output layers get activated essentially with the softmax activation function, because the face can the face can't be like at the same time young and old, or like male and female in our representation here. So we're using the softmax activation function. And this little design that I did here, what I found is that it's actually performed, like from my experiments, right, it performed better than like 2 separate networks. And if you think about it, like it probably makes sense, because to estimate to like estimate a face's gender, you kind of need to learn representations of a face, and to do this, to like estimate the age, you also need to learn the representations of a face. And so kind of combining that into a single neural network is something that I found to like boost the performance and obviously the inference time also. So this is pretty much all there is to the neural network, right? We got our neural net in the TF Lite format. Now it's the time to figure out like where do we like even start putting it like on Android, right? Now before we talk about the approach itself, I want to give a shout out to Esteban Yuri and his TF Lite facial recognition project has given me quite a bit of an inspiration in this one. And the approach itself, right, is we'll take the TensorFlow Lite object detection example app and we'll rebuild it into the age and gender estimation app. Now at first it may sound like what, like you're gonna take like object detection app and like turn that into like a age and gender recognition estimation app with like face detection and everything. Kind of doesn't make sense, but if you think about it, it's much simpler to take and I'm using in this video like the most recent Android Studio version. It's when this video comes out, right? The most recent Android Studio version, the most like recent examples version. It kind of makes sense to take the example where TF Lite has been installed and like optimized to perform well on like all the devices, and it's a good place to start, right? And it's incredibly easy to also begin building something with the TF Lite examples. In fact, my first video in the TF Lite series talks about that, and it's pretty much a 15-minute video as to how you can get started with like Android Studio and like examples, like both of them combined. So so this right here is essentially the the TensorFlow Lite object detection example app that I've rebuilt into the age and gender estimation app. And the first thing on our path to making it work is to take our face model, in my case it's called face model v5.tf Lite, and put it in the assets folder. An Android assets folder is essentially where you can kind of strap the various files that you like your APK file that you like your application to include. And here you can see the tag.tf file, which is the object detection network from the original TensorFlow Lite app, right? I just essentially put here the face model .tf Lite right here, and so that's essentially the way of packing our network into the app itself. What's cool here with TensorFlow Lite is that like with OpenCV we actually couldn't read the OpenCV for Java. We actually couldn't read the networks from the assets folder directly, right? But here we kind of can, which is really convenient because you don't have to like say download the neural networks from the internet upon say the first launch of the app. You can just kind of, if it's a small enough network, you can just kind of strap it together in the APK file and like you're good to go. So that's kind of what's happening here. So I've touched on all the setting up Android Studio stuff in my first TF Lite video, which covers like how to enable the developer options, how you can like take the USB cable and then plug it into your phone and then be able to run the apps, how to like enable the developer options, and all that fun stuff. Now let's actually talk about the structure. The structure that you're seeing here, it's essentially the same file structure from the most recent TensorFlow Lite object detection example. So let's talk about that structure first, and then I'll show you which aspects of it like I actually modified and changed. So the main kind of file with code is detector activity, and so like the main so the two main files where like all the actions happening is detector activity.java, which has like all the code that's like about initializing the neural networks and initializing the face detector and for like cropping images, like rescaling them, passing them through the neural network. And then the actual piece of code right here, it's like in a little bit of a like different department here, that's like actually all about taking the cropped scale to the right resolution image and actually getting the results from the neural network. It's the TF Lite object detection API model, and here we'll like modify this recognize image file to from like the object detection to age and gender estimation essentially. The honorable mentions here also are camera activity, which grabs frames from the camera and essentially throws them at detector activity. Camera connection fragment and legacy camera connection fragment, which like set up essentially cameras and all the like configurations around them. And the legacy one like for older devices, and the just the normal one for like newer devices essentially. I think it's like the difference between the camera API and camera API 2 type thing. So essentially the first thing that I did here in the detector activity was, the input resolution for the original neural network was like 300 by 300, I think. And since remember our network here, its input resolution is like 80 by 80 by 3, we put the OD object detector API input size as 80. All the variables here are named the way they were named for the object detector. We're kind of like saying, like keep all the cool stuff that's like been set up for the object detector in place. Just let's change the neural network essentially to perform a different task, and then add the phase detector and all that. So as you can see, I changed the input resolution for the neural network here, and the name of it, and yeah, I'll be essentially giving you like a walkthrough, and I'll try to focus like on the main part. So I may omit some of all the changes that I made, but I'll obviously link to the code and you'll be able to see them yourself. But I'll try to like essentially not waste your time and like give you all the stuff where I kind of like stumbled and which was hard. So first thing, in the newer example, right, in the older version everything was fine, but in the newer version there was actually a problem, and there was actually the problem with loading the neural network. So essentially in the newer version of example, like in TensorFlow they did something with like metadata and the fact that you need to have a metadata file, and so the network wasn't loading. I essentially found this workaround on GitHub that I modified here to just normally load the network from assets, and it worked, and it like loaded the network. So now let's kind of think for a second about what it takes to build a age and gender estimation app. So you need to grab frames from the camera, check. Then you need to use some sort of face detector, right? Because all the faces that you see, right? We need to locate the faces in the camera frame that we grabbed. So we need to find the faces like they're bounding boxes. We need to crop each and every face there and pass all those faces through the neural network estimator. So we need some sort of face detector here. And so I'm using here Google's Firebase face detector, and to include it, I essentially need to go here in the Gradle and here add the implementation, which essentially downloads all the face detection stuff. So that we can then first find faces. And in the detector activity, you can see here the face detector being initialized and then used. And so again, like the basic structure, right? Grab a frame, like locate the faces, then iterate over like every face, pass each of the faces through the network, get the outputs, like draw those bounding boxes, and be able to estimate the ages and genders of the faces. So now let's actually see how it works in the code, and it's gonna be something. So let's see. So everything starts in the camera activity file, which this function here, onImageAvailable, essentially gets activated whenever there's like a new frame being grabbed from the phone's camera. And so this function activates the process image function, which is this guy here, which essentially takes the image and passes it through the face detector. And then face detector, if there's like at least one face being detected, activates this onFaces detected function. And onFaces detected function, we're essentially right, and this is we're like iterating over all the faces that we found and resizing all the faces in the in our neural network input size. So in our case, it's 80 by 80. And so we're resizing, each of the faces that we found in the image, and then we pass it through the detector that recognizes the image. The reason why it's called detector, again, we kind of have face detector and detector. It may be a bit confusing, but it's essentially the way that it was called in the object detection example app. So, but in our case, it's no longer the detector. Now, you may actually kind of wonder, and as you can see, the detector guy here, it outputs a string. So, and so this detector guy, the actual function recognize image actually lies in the TF Lite object detection API model file. And so here's what's interesting about it. Here you have to, so this guy takes the image that we're working here are like, it's not, like in OpenSea we have like math images. Here we have bitmap. So the recognize image function here takes bitmap as an input. And here, because of the, for instance, here I take the input image and I divide the pixel values by 255, which is what white threshold here is. As a way to, because that's what I did with the neural network, right? Because the training images were normalized to have pixels in range from 0 to 1. So that's that. And then here's something like really specific and interesting to TF Lite into Android, because we have to first define the output map, like kind of the array that'll be filled with the information once the inference happens, once the image goes through the network. So in our case here, I define the output map, and I have the output map include the age map and the gender map. And here we see the variables age size, which is it's essentially 4, and gender size, you can see it's 2, because remember, here in the neural network we have because we have 4 neurons, 4 types of ages and 2 types of genders in our representation here. So we kind of like first define like these 2 arrays, saying essentially like, hey, in our output map there are 2 elements. There's the age map, and then there's the gender map. And the age map, it has like 4 elements, and the gender map has 2 elements. And then this input array guy, it's our image, and then like this is the actual line that performs the inference, that passes the image and gives us the output. So TF Lite ran from multiple inputs and outputs. It includes the input array and the output map. So the input array is the image, and the output map is our like predefined structure for our outputs. Here you can see some logs from like, logging the ages and genders in our case. And here's just some simple code, because like the way the network works, the way the whole system works is that, for instance, we have like 4 neurons for the ages, right? And it's essentially like an array with 4 values. Sound like this, right? It's like 0.1, 0.2, 0.4, and like 0.3. Essentially, they should like add up to 1 because of the softmax activation function. But essentially, for instance, right, say this neurons here of all 4, right, has the highest value. What that means is that the network thinks that it's the first, the second, and the third, that the third neuron represents the age group from 40 to 60 years old. So the network thinks that that the age of the person's, it's in between 40 to 60. And we know that because the neuron that's responsible for that age group has the highest, activation value. What we have to do to essentially be able to then tell that, like, hey, this face is like middle-aged, say, right, is to determine which index here has which index in this array of activation has the highest value. So essentially, here's some real simple code that goes and finds the maximum element of an array. Like, it's super simple here. And, for instance, in this case, it'll give us the index of 2, because it's like 0, 1, 2, and that'll mean it's like a face middle age. If we like swap the numbers, this will be like the kind of like adult faces, young adult faces or something, right? So that's kind of how this part works. And here we have like a nice list where we essentially here make our labels, make our label string that's like the actual writing that you see, like, age and gender, right? And the reason why we needed those indices is because when we construct this label string, we say that like age is essentially that age, equals to like an element from the age list, which is defined here with the index, right? And if the index is like, say 2, it's 0, 1, 2, that'll be like a middle-aged face. And if the index is like 1, it'll be like young adult face. And same thing with genders, right? Whichever neuron has more activation value, that's the gender that we think for. So if it's the first neuron, it'll be a female face. If it's the second neuron, that'll be a male face. So, that's kind of how it works. The thing to note here is that the function recognize image in the TensorFlow Lite object detection API originally was not outputting the class of string. So I had to go here in detector and change it to output a string value, such that I could just have this function here output like a string of text with like the ages and genders. And also, obviously modify the output type of this function here. So there you have it. Now, let's talk about something that's strange, but that's hopefully going to make more sense as we talk about it. So our age and gender estimation app is actually more similar to an object detector than you think. So object detector detects, object, draws bounding boxes around them, and the type of class that the, bounding box is. It's a cat, it's a dog. Our app draws bounding boxes, but just around faces, and then a neural network estimates the age and gender of a face. So the basic structure of how the outputs are written, it's kind of similar. So, object detector gives us a bunch of objects with like bounding boxes and their classes, and here we're getting also a bunch of bounding boxes around faces and the classes of the face, in our case like age and gender. So since it's based on that object detector app, and what it implements is and this part confused me so much at first, like you have no idea. So essentially I was thinking like, how can I like go and like draw a rectangle, or like where's the actual like drawing process happening, like where's the because we're looking around this code and it's kind of all nice and shiny and whatever, right? But I'm not seeing anywhere in detector activity anything even remotely related to draw a rectangle or put some text. So where's that happening? And so after doing some digging, I found out that where it's happening is object detection app, the original one, implements object tracking. And so all of the detected objects from the object detector first gets passed into this multi-box tracker file, into this multi-box tracker class, basically, where they're being tracked, and inside of that file is actually where the drawing is happening. So let's kind of like follow the labels, I guess. So first, to pass our data, to pass our label and bounding box coordinates, because that's all we need. We need to know where to draw the bounding box and what to draw like on top of that bounding box, right, in terms of the age and gender. So we create this detector that recognition result. So the important part that we pass in this result guy here is the result label, which remember, it's the string of text that we formatted here that has been outputted by the recognize image function. So we then add to that result the bounding box location, which is, we learned that from the face detector, and we essentially add that to the map recognition array. Then update results function takes those map recognitions that we got, and that function passes those updated. This is all the structure from the object detector app. So I didn't come up with that. it's, as I was saying, it's the part of like converting the object detector into this new thing. So then inside of the update results function is where tracker actually gets the mapped recognitions with all of the bounding boxes and now the label strings, and so they're being then printed right here. I actually modified the output label string here, and as you can see, it had a few things actually. So essentially I made it like shorter, and I made it not include the confidence. So originally it say something like, like it's a dog like 100%. As you've noticed in my app, it just says like 15 to 40 age, or like male. It doesn't like output the confidence. But if you want to do it, you can experiment with the label string here. But that's where actually, you can see the draw text and like draw round rectangle stuff. This is where like all of the drawing functions are happening. And so if you want to like play around with like actually drawing stuff on screen, you do that in the multi-box tracker. So super excited to clarify this part. Like it was confusing to me so much when I was starting out. So hopefully it kind of helps, And so then of course the basic way of like how you debug pretty much all of the Android apps, right, is I take my phone here, I set transfer files, Android Studio like recognizes the it starts to recognize my device, and then I can click debug detector activity, and it's going to first Gradle build this application, and then essentially builds the app on like my device right here, and yeah, that's pretty much what it does, right? It's pretty cool stuff. And so that's pretty much all that I wanted to say. You can think of this video, as I was saying, as pretty much an example of how you can train neural networks, and then deploy them essentially on like mobile devices, on like Android phones with TensorFlow Lite, where you can then like, use them like in the actual real world, which is pretty cool stuff. So as I was saying, I'm essentially open sourcing this app and the neural network that I trained. So feel free to, if you use it and if you find it valuable, to in some of your projects, like drop a link to this video somewhere, like in the credits or something like that, in the references, if you found it useful. The code will be on GitHub, right? And I'll basically like take this whole project here that I just like built on my phone, right? And I'll upload it to Google Drive, so you can like just basically download it and run it right away, and it like should work, which should probably that's definitely something that I think would be useful. So give this video a thumbs up if you found it useful. Subscribe to my channel to stay up to date with the content that I made. Follow me on Twitter. I recently started working and making a lot of videos that don't necessarily go to this channel, and so the best place to find updates and what I'm up to is like on Twitter. And please post your questions, like suggestions, in the comment section down below. Always, fun to jump in, and chat with you and to help out in the ways that I can. But really, I hope that you find this video useful, and I hope that you enjoyed, and I hope that you guys are safe and you're doing well. So thank you guys for watching, really.